will review Section 5.2 on factoring by grouping. Here is an example of what factoring by grouping refers to. In this example, we're asked to factor 6 times the quantity 3x plus y minus z times the quantity 3x plus y. This example was explained in Section 5.1. When we're looking at a grouping of numbers, 3x plus y was our common factor amongst these two terms, and that is being multiplied on the left-hand side by a 6 and being multiplied on the right by our negative z. So in this case, we take our 6 and our negative z, or minus z, and we group them together, and that grouping is being multiplied by 3x plus y, the common factor. And that procedure that you did is called factoring by grouping. So let's look at this example. We want to factor. We want to first look and see if there's a common numerical factor. And in this case, not every single number has a factor that is greater than 1. So then we can ask, does every single factor have a variable that we can factor? And in this case, again, not every single term has a variable. 21 is a number without a variable. But some of these terms do have common factors, common variables, or common numbers as factors. So what we can do is we can factor by grouping. We can group the terms together to factor out greatest common variables or greatest common numbers that are factors. So let's look at what might be if we grouped the x squared with the 7x, what do these two have in common? Well, they don't have any larger number than a 1, but we could factor out a common variable. They both have an x. Let's group 3x plus 21 together. They do not have a common variable, but they do have a common number factor of 3. 3 times 7 is 21, and 3 times 1 is 3. So what we can do is we can factor out the x from the first two terms and factor out a 3 from the last two terms. If we do that, what we're left with on the left-hand side would be x plus 7, x times x plus 7, because we factored out this x. And on the right, factoring out this 3, we would be left with 1x plus 7. What do we notice now? These x plus 7 are the same that we're multiplying by our x and our 3. So we can simplify this even further and combine x plus 3 and multiply that by our common term of x plus 7. So our final factored form would be x plus 3 times x plus 7. Let's see some more examples to get some practice here. So first we can look at our expression that we want to factor, 2x squared plus 3x plus 6x plus 9. None of these have the same common factors, but in this order, if we grouped the first two and group the second two, we can find common factors or common variables that we can factor out. In the first case, we can factor out a common variable of x, and in the second case, we can factor out the 3. 6 divided by 3 and 9 divided by 3. 3 is the greatest common factor. So if we do that, we would be left with x times 2x plus 3 plus 3 times, we know we're factoring out the 3 here, and we factored out the x here. 3 times 2x plus 3. what do we notice? Again, inside our parentheses, these values are the same. So we can combine what we're multiplying on the outside, x plus 3, and multiply that by 2x plus 3 only one time, because it would be the same. Here's just one more example, factor by grouping. We'll group the first two terms together and the second two terms together and factor out what do 4x plus 8y have in common. We can divide by 4. The variables are different. And in the second case, they both have a factor of a, but no numbers and no other variables would work. So if we take the a out, we're left with, remove our a's here, we're left with x plus 2y. Take out our 4's, we're left with x plus 2y. And x plus 2y is the same as x plus 2y, so we can combine our external numbers, 4 and a, and multiply that by x plus 2y. One more example, factoring out in grouping the first two terms together, we can factor out an x. Grouping the second two terms together, making sure that we're working with those negatives as well, we can factor out a -2, which would make this both terms actually positive because they were both negative. And if we do that, we end up with the same grouping of what we'd be multiplying by. So you can combine those numbers on the outside, x and -2 into one parenthesis, x minus 2, and multiply that by 2x plus 5. In some cases, you might need to rearrange the order. So for example, if I'm grouping and I said, oh, let's group these two terms together, they have no common factor. There's no factor for 8 and 21. There's no common variables. That just would not work. So then maybe you say, well, let's factor these two in the middle together. Well, they both have a b, and they both have, they're both divisible by 3. Okay, if I did that, could I put these two together? Well, they both have an a, and they're both divisible by 2. Is there any other way? So we might want to look and consider, oh, A, C, and AD both have an A. Yep. What about 6BD and 8AD? They both have a D, and they're both divisible by 2. And 21 and 28 are both divisible by 7, and they're both divisible by C. So we could rearrange the order so that we have 8AD minus 6BD minus 28AC plus 21BC, because in this case we had both 7 can divide into both 28 and 21, and a C, those are common factors. And on the left-hand side, both 8AD and 6BD are divisible by 2, and they both have the variable D. So in both cases, we're able to pull the most out of each, a variable and a number, instead of just one or the other. And from there, we can simplify. We do end up again with our groupings being the same, so we can combine those. And then on the outside, we would combine that 2D and -7C for our term that we would multiply by here.